Hi, Maor.
Yes, I'm here.
Okay,
Hello.
perfect. Did you want to go ahead and test your slides? Make sure that you can share your screen.
Yes. Can you see my screen?
Yeah, perfect.
Right. Now let's
Okay,
see me. Can you see me?
I can see you.
Perfect. Now the slide is shifting slides. Great.
Okay, so we're going to kick off at top of the hour. I will put a, go time note in the chat, and we will be good to go. But did you have any questions?
No, just one thing to comment. The company name went through a rebrand like 2 weeks ago. It's not White Sauce anymore. It's Mend.
That's, yeah.
Okay.
I just
Perfect.
changed my speech, so take care of it.
Right. So beside that and talk, I think it's an interesting topic. Hopefully we'll get a lot of questions. Let's see how it goes.
On the previous meeting, the presenter was a little, I don't know if it was a little too fast, but we ended up 10 minutes before the end. In 35 minutes, he finished his presentation, and we didn't have enough. I had to take some question from my own pool of questions. So
Yeah,
I don't know if
my
you,
computer froze, so I couldn't pull up the list of questions if there was any provided. So
yeah, there were two provided, and I had like 3 or 4 from my side. So we were able to add some content. Hello, everyone. Welcome to the Exhibitor track. I'm Jean-Denis Laval, volunteer in the OWASP community, and I will be moderating this session. During the next 45 minutes, you will be listening to Maor Kuriel from Mind.io, presenting cheap product with confidence, securing your software supply chain. Please submit any questions you have during the session in the Q&A tab, just to the right of this video in the Wova platform. I will be asking Maor your question in the last 10 or 15 minutes of this session. Please note that the chat function in Zoom is disabled for attendees, but you can leave comments and chat using the chat tab in Wova. Maor Kuriel is product director at Mind.io, formerly known as White Source, leading the area of cloud native solution. He has over 10 years of information security experience. As a product director at Mind.io, he supports organizations in their digital transformation and improves the security through DevSecOps. He's passionate about delivering easy-to-use cybersecurity products and defining the future of cloud-native security. Maor, the floor is now yours.
Thank you very much, guys. Very happy to be here. First time I'm presenting in OWASP, so it's a very exciting presentation from my end. I'm also going to talk about a topic that I'm very passionate about, supply chain security. I've been past year that I've been working at Mend, and before that I was working for AppSecEU. The entire cloud native ecosystem, there's a lot of attack breaches, there are a lot of attack vectors out there, but one thing that gathers everything into a single problem area is supply chain security. You can tackle the container or serverless and infrastructure as code and do whatever you want, but supply chain security is something that because the shipment to the cloud and everything in the cloud is software defined, it's a very, let's say, lucrative, it's a very attractive attack vector for adversaries. And when they're attacking your supply chain, they can potentially reconfigure and do whatever they want with your environment your application, and we're going to cover a couple of examples during our slides. I would love to get as much questions as possible, and if we won't have enough time, my email is over here, my Twitter account. Feel free to reach out or through the Slack of OWASP. I love to talk about this topic. For you who don't know, MEN is an AppSec company, so this is also something that we're doing on a day-to-day basis. So this is something that we're very passionate here at our company. Okay, so let's start. First of all, slide. This is what we're going to go over today. Our journey today is going to be from the entire defining the problem area, getting a clear understanding why why we are talking about this. From there, we're gonna go and see how we can address it. One thing that I want you guys to take from this talk is not only the things that I'm saying. I'm going to go over a couple of reference architects from the CNCF, best practices from the field. I'm going to go over about open source project that I'm involved in and that you can use. Actionable steps. I really hope that you can finish this talk and go and Google all the stuff that I'm talking about from the CNCF, from for the open source project that I want to talk about, and start using it. So you'll be able to get some value, not only from my personal knowledge and my experience, that you will actionable stuff. So I'm going to talk about a couple of approaches that there are out there. For example, one of them, shifting left, and what is good about it, and what I'm looking at, and is what it's missing. How, as I said, we're going to define the problem area and going to cover at the end of it, because this is a huge topic, supply chain security, where I can give a 1 week course about this and all these topics, but I'm going to focus only on the initial step of the supply chain, on the source code, and the importance of up-to-date dependencies and how to introduce automation into that in order to save you time and keep you up to date and be as secure as possible at the beginning of the supply chain. With that, let's jump to the first slide. We're moving to the cloud. All the workloads, all the applications, the digital transformation is happening in the past years. Cloud adoption leads to DevOps. DevOps leads to agile coding. When you do, this leads to a lot more developers writing code, microservices, and a lot more code is being shipped out. The problem with that is the security teams are being kept in the same area. They're finding very hard to deal with all this information, all this content. They're being bombarded with all this stuff. They need to adapt really fast to the pace, to the velocity, to the technology. Okay, and there's a lot of stuff over there they need to know how to attend to. Okay, they are shifting from simple waterfall SDLC to an agile one. And with that, the attackers are looking at, okay, the adversaries are looking, okay, how can I compromise the organization for data mining, malware, whatever they want, personal gains? What's the best way to hook into the system? So in the past year, resources, and you can see the statistic right in front of you, we're seeing that supply chain attacks are on the rise. The main reasons is that supply chains, when you compromise a simple pipeline, you can affect a lot of resources out there. And the increase is very popular with all the examples. I think the most popular one that you can see that is listed here is the SolarWind, that everyone heard about it. The Twill also, of course, but all the other stuff are very popular if you're in the security, are very known if you're in the security ecosystem. I'm not sure that you guys are familiar with it also, but the boundaries of security when you're looking at supply chain management extends from your source code into runtime. And it's very challenging to get a clear understanding on where do I want to start. Where is a good place that I need to focus my attention? On the runtime, but it might be too late because my code is already being compromised and it's in my production. In my supply chain, but there is too many components running over there. How I know that every component is using the same control, security control, sorry, on the dependencies, on the pre-build, on the GitHub, but do I have the right content of the security exposure, the risk exposure? So there's a lot of stuff, there's a lot of questions, and we don't know. And with all these questions, with all these challenges, this is one of the, this is a very favorite line that I like to quote. The purpose of technology is to solve problems for businesses, not to create one, not to be one. Okay, and this is a lot of people, a lot of customers that I'm talking to in the past years are saying, okay, when I'm moving to the cloud, there's too many challenges, too many problems. Okay, I need to put a stop. Let's take it down a notch. I don't want to go as fast as my business wants, but that's also not a very good approach, because the customers, the market does want everyone to go there. So we need to find a solution. So how you can solve the solution? The best way to solve something, and of course I'm being sarcastic here, is ignore the problem. Okay, I didn't see it. Nobody saw me addressing it. Nobody can blame me. That's not, of course, that's not a valid approach. But the most traditional way to do this stuff, to address this, is look at the new compliance framework with the new paperwork and implement new rules and more training for the users. And when the users are failing to align with the best practices, blaming the users, not working, okay, let's do a different compliance regulation. And again and again and again, it's a vicious circle. And so when it comes to cloud adoptions and agile, people really love to go and say, okay, let's shift left. Let's take all our security controls. Sorry, just a second. Let's take all our security controls and run them as early as I can. Okay, and this will solve my problems. Okay, I don't need to implement all the different stuff. But when we are looking at this, okay, shift left is not enough. The main reason why it's not enough is the first thing is there is no clear process validation. When you're looking at the entire SDLC, the entire pipeline, how can you get confidence and assurance that your security check, your SAST ran on your code repo, your SCA ran on your open source components, your CI/CD artifact was scanned accordingly, and all of these scan ran on the same pipeline, and all the security checks and the results align with your best practices and the security guidelines. It's very challenging. Usually all the application security tools that are out there, SAST, SCA, IAS, DAST, name it, are not communicating with one another. There is no one platform that is doing this. By the way, if you're looking for a single platform, we can reach out to me, but that's different topic. There is no process integrity, no process. You have no idea if the CI materials that you're using, the products, were tampered with. For example, what happened with the Solar Blast? When they checked everything, they scanned everything, the signature of the component of the DLL that was tampered with, that communicated to the CNC server and downloaded the malicious payload, everything was as expected. But we all know how it ended. And the main reason is that no integrity checks were ran. Nobody knew exactly that, which brings me to my third point, no agent validation. Nobody had clear insights on if the personnel, the application, the components are doing what they need to do and not doing malicious activities, or even not malicious activities, just doing stuff that they're not supposed to do. there is no validation over there. So that's the main challenge over there when we're looking at it. And the quote on the bottom, that it's pretty much saying that with all the advance of technologies, with all the advance that we have in cryptographic algorithm and security techniques, we see that security practices are not keeping up the pace. And this is not something that I said. This is one of the chairman of the CNCF security tag told. That's one of the biggest groups out there for cloud native security. Okay, so you ask yourself, with all these challenges, with all these problems, what can we do? How can we challenge? How can we fix? How can we start addressing all these problems? So a very good start that I see is go to the supply chain security best practices white paper of the CNCF. It helps you to fill the gap on the best practices for supply chain security. It's evaluate a lot of tools that helps you define best practices for supply chain security. It revolves around four main key principles: trust, automation, clarity, and mutual authentication. And I'll elaborate a little bit about each of them. Regarding trust, it helps you to create some sort of guidelines and understanding how to build trust on every step of your supply chain. And it's recommended to do that with a combination of cryptographic attestation and verification. Automation. When it comes to automation, it's very crucial because of the challenge that we talked about in previous slides. There's a lot of pipeline, there's a lot of microservices, a lot of developers are shipping out code, so there's a lot you need to implement automation into your security of your supply chain, because this can significantly reduce possible human error and configuration drift. This takes us also to a previous slide, blame the user. Clarity addresses the challenge of that the build environment used in the supply chain should be clearly defined, limited scope, that it's the action that are being executed are the action that we believe and we want them to be executed. And of course, authentication. All entities operating in the supply chain environment must be mutually authenticated using hardened authentication mechanism and key rotation. You don't want to create a super user applied to one of the objects or one of the entities that are running and forget about it. That's the best way to infiltrate the supply chain. Now, I read this document. It's an amazing document. There's a lot of good insights, but at the end of it, I was looking like this. The main reason that I was looking confused and I didn't know, okay, there was a lot of running moving parts, and I was very challenging in creating a full picture. It's not so obvious of how all the processes and tools that are described in the document tie all together. It's not so obvious that how the practices how are they actually relevant to my specific environment, to my pain. There's a lot of stuff out there. Even if I'm taking one of the best practices to my specific environment, you won't be able to 100% replicate this to a different environment, to a different customer, to a different, for example, running Jenkins on AWS or with the code pipe. You won't be able to run it on Azure DevOps or with Circle CI because my environment is running based on Java and he's running on C. And there's a lot of different components, and you need something much more clear. So when I finished reading this, I didn't know where to start. I didn't know exactly what tools were right for me and what is the right path. And if I was confused, I'm sure that a lot of people out there were confused along with me. So this brings me to the second part. So what can I do? It's a very good question, guys. I know that all of you guys thought about it at the end of the previous slide. So the first thing that we must do is clearly understand and define the problem scope. I talked about it a little bit at the beginning. The problem scope, for supply chain security, is not only on specific section of your CI/CD pipeline. It goes from your source code onto the runtime to the actual deployment. And for each of the steps that you see here, you need provenance verification. You need to gain assurance on the origin of the artifacts. You know, to understand that the artifact that you're using is exactly what you think, or what you think that he is. A specific open source project is not that you're using, or a package is not being wrapped around in a malicious code. The next step of that, you know what you're using. You need to gain clear understanding on the actual steps and actions that this component is taking. Not only looking, on the bill of materials of that specific object, you need to also look at the actions and the steps and the activity that this component is doing. And this goes for your pipeline steps, for steps in Jenkins or in Circle CI. This goes for your actual code that you're writing or leveraging, on your artifact that you're building, your runtime configuration, all of this. And for each of the steps, or each of the components that you're right now checking, you need to create a circle of trust, dependencies. Constantly check the artifact dependencies and see that nothing changed, and you have full trust with it and provenance of the artifacts as it's used. So after clearly defining the problem scope, I found that this white paper, this reference architect, is a very good place to start, because this is a prototype that you can take as a proof of concept, as a POC guide, and this gives you a very clear understanding on all the components that you might have in your supply chain environment, how to introduce automation, how to introduce security by default. Okay, and this was produced in the past months based on the massive feedback that we got, that the field got on the previous document, because we want something that we can take and start using it. And I know what you guys are thinking right now. Maor, you just talked about the white paper, and you're giving me another guide. I don't want a guide. I want to use something that, like you said, I want to take it and I want to use it in my environment. I want to learn from it. On-job training. You are 100%, but in order to run, you need to start walking, and this is the way that you walk. And after you read this document and you fully understand. By the way, it's not that long. I think it's like 20-40 pages, even less. Okay, and it's a very good one. I highly recommend go and read it. But after you finish reading it, if you want to do the actual steps, the practical steps, and implement them in your environment, go to this open source project. This is an open source project that was created by Citibank, specifically by Michael and Brad from Citi, and they contributed to the OpenSSF. It takes all the secure software factory best practices, implementation guidelines, and translate them into actionable steps. It uses open source projects, only open source projects, in order to create a set of tools, patterns, and policies to help you build supply chains and pipelines, and create artifacts with confidence and with traceable provenance, which means that you can take the pipeline that you created here and easily translate it into any system that you have. the best practices, the open source that they are using. Again, for automatic, everything is around automation, everything around security, and it's also compliance with the SALSA, the best practices of SALSA, which is the framework for I forgot the exact acronym. Just give me at the end of the slide, I can check it. But it's compliant with all the SALSA levels. It uses, it helps to implement automated signing for your artifact with SIG store and cosign. For the pipeline management, the framework and the observer, again, you need to check everything. Okay, it leverage checkpoint change and pipelines. Admission controller is being implemented here with Kyverno. Identity attestation is being generated by Spire, and everything is running on top of Kubernetes. A very amazing project. Personally, I've been familiar with this project, I think, for more than 6 months. I've reached, Michael gave a lecture about it, like in the previous KubeCon, and from there I've been start working with this project. Amazing project, very simple, simple to use. The Fresca and the supply chain factory helps us to focus and to address the problem scope based on the different steps of your SDLC. It divides you to the pre-build, the build, and the post-build. What it does pretty much is look at each of the components and gives you the best practices, the steps, the tools in order to implement security and align with these guidelines, with the verification, trustworthy, and dependencies for each of them, not only for a specific component, which means for you guys that if you in your environment are in charge only on your CI/CD system and you want to boost the security and implement the best security and guidelines and align with these with these values, you can just go read the guide, look at the tools, and take whatever you want from it. Same thing goes for the pre-build steps. If you're only working with the GitHub repo, dependency, open source management, you can also do the same thing, and the post-build. Okay, so again, it's a very good guide, and the best practices here helps us to create a secure pipeline end-to-end. There are more, not only the guides that I just talked, the guidelines and the best practices. I want to talk to you guys about software bill of materials. Now, there's a quote here from an article that I found a way back that I'm not going to quote it, but it helps us to understand that software bill of materials are very valuable for organization, especially when they are tackling the challenge in supply chain security. But while SBOM are useful to organization, it does not guarantee the actual insights that you want to get. They provide only information on the organization. They provide only information to organization about the actual components that they are using in your software. The list itself is not enough because it doesn't give you the actual the exploitativity, the contents to the risk factor of each of the components. And not all vulnerabilities were born alike. Because one vulnerability, one open source project, one package that is being, let's say, very high risk, there is an attack vector for one of them. When we take the same package and run it on a different program or on a different version of the product, the risk might shift. You need to add this information into your equation. So SBOM is a very good start, but it's not something that you can rely on. For that, I highly recommend to integrate also a thing called VEX, Vulnerability Exposure Exchange. VEX is pretty much a standard and that gives you a clear understanding on the content that is provided by your SBOM. It assists you to communicate the actual exploitability of the vulnerability. And it's a very powerful standard that declares whether the product is vulnerable to a specific vulnerability. So when we are protecting the supply chain for development, we need to get also introduce automation tools such as VEX and SBOM. It gives you the necessary insights in order to manage your supply chain in a very efficient way. Otherwise, you just get bombarded with information that is not relevant for your needs. And it helps us, it saves valuable time, because if you see right now, and this is one of the examples, by the way, there's a link on the bottom that you can go and you can get all the information on VEX on the standard, and I also took the screenshot from there. As you can see, a specific vulnerability that you see over here on a different, on a specific vendor, on specific products, okay, it has a different effect. The risk factor changes. And you need to get this insight in order to get clear understanding and define guidelines and steps of actions for your organization. Otherwise, if you think that everything is vulnerable, a specific package is vulnerable, you might send your security administrations or developers for a wild goose chase. Now, I said that addressing the problem area, it's very good to divide it to the following three pillars: the pre-build, the build, and the post-build. So right now, what I want to do is I want to focus on the pre-build phase. I want to focus on talk to guys about how to keep your dependencies up to date. And some of you guys might look like this kid right now, because why you talked about the full picture right now. Now you're focusing on dependencies, on the pre-build. Why you want to take us on into that? Why it's so important? Good question. You guys have very good questions so far. I love it. So the main reason that I want to talk about this is that when you're keeping your update up to date, what's in it for me, you prevent yourself from exposing yourself to vulnerabilities, because the latest version it won't have all the vulnerabilities and exposures. You always get all the latest features and API, bug fixes, and zero-day fire drills, which I don't know if some of you are familiar with this phrase. A fire drill means that a new vulnerability was just discovered, and your customer is pressuring the company, okay, fix it right now, fix it now, fix it yesterday, okay? And your company is coming to you and said you need to fix it, but you're 18 months and 10 releases out of date. What would you do? How can you do that, this stuff, without breaking the build, without getting all the confidence? That's a fire drill. That's a pain, that's a challenge, that's a very frightening thing to encounter. And when we are looking at the statistic about this, when you're constantly up to date, you're already avoiding 90% of newly discovered vulnerabilities, and known vulnerabilities are exploited in 60% of all known breaches. The survey, the full information is in the link below. Okay, I convinced you guys. You guys want to stay at the latest and greatest version of all your softwares, but there's a pain. It takes time. First of all, you need to understand what are the dependencies of your project, open source projects, Docker images, internal dependencies. That's by itself is a lot of work. Then you need to go and find, do I have an updated version? If I have an updated version, can I use it? Can I update without breaking my build, test and release it? Okay, then I need to actually open the PR and update the dependencies and do all the steps that are steps 2 and 4 on each of the dependencies. On the right, you can see also the estimation of the time that it takes. Okay, you can blindly upgrade everything. You can blindly go and say, okay, I'm fully covered, because there's a lot out there, and human errors always happen. So how can we help you guys with this? I've talking about a lot of tools, a lot of guidelines with Fresca, the open source project for the entire SDLC. So right now we're going to focus on the pre-build. For that, I want to take you guys and introduce you guys with an open source project which is called Renovate. Renovate does exactly all the work that is described in here. It scans your projects and identify all dependencies for open source components, infrastructure as code files, Docker-based images. It goes and looks for your actual updated dependencies if they're out there. It automatically opens a PR for you and gives you clear insights on the on the release notes, commit history, and test status. Now, one thing that I found very valuable, and all the people that are using it also, it gives you the merge confidence. Merge confidence means for you guys that, okay, I want to, if looking at the first example, I have the Remarks Stringfly version 8.1, I want to upgrade to 9.0. Based on the statistic that Renovate collected by himself, he gives you the insight that 60% of the guys, the developers that upgraded to version number 1, survived the build. So 40% didn't survive. So it defined a low confidence and zero adoption rate. But if we're looking at the bottom example, you get clear insights on all the guys that upgraded and get a very 100% pass confidence with adoption and didn't break the build. Pretty much works in a very simple, non-intrusive way. By the way, it not only can open the PR, it's also based on your configuration. It can also create some create a merge if you merge the fix automatically. But this is a configurable. You can define it for here or for here. It's a very non-intrusive, manage everything, and all the developers, I just came back from KubeCon like 2 weeks ago. People that I talked about it, about this project, love it. A lot of people are using it. Okay, I've been talking for 43 minutes, 44 minutes. Okay, let's start wrapping it up. And I also want to give you guys time for questions. So what did we cover? The main points that we cover in this slide deck. The first thing is that we need to gain clear understanding that supply chain is a very powerful attack vector. Let's not put all our hopes on security scanning that is being done only on single point of the SDLC. Of course, shifting left is not enough. You have to introduce provenance identification, trustworthiness, and dependencies, all the values, that we talked about. SBOM is a very good start. It's a very good spot, but it's not enough because it only gives you the visibility to the actual component that you have. If you want to get inside the content that of a specific component package has, what is the risk factor? You need to introduce VEX, the exploitability standard. You have to have, especially in cloud native environments, cloud native supply chains, you have to have the content for your environment, for your risk. Otherwise, you will get bombarded with a lot of information. You won't find yourself, and you lose it. And I'm saying it based on a lot of talks that I had with customers. Go and read the Secure Software Factory. If you guys are managing your supply chain, if you are interested in this topic, if you want to learn how to beef up your security, go and read it. You'll get a lot of information from it. If you want to get some tools that will help you with the day-to-day work, go and get familiar with Renovate and Fresca. One will help you to keep your software updates up to date in a very simple way. The other one will help you create artifacts, secure the entire, give you examples and tools and guidelines that you can use on a day-to-day in order for you guys to implement in your environment. From here, I would like to open it for questions. And of course, guys, this is my email, this is my Twitter. Again, if you guys want something, if you want to have questions right now, I'd love to answer. If not, we can also take it offline, but I would love to hear anything from you guys.
Okay, so first question I have is regarding provenance verification. If all package managers out there were requiring package signature using best practices, then wouldn't we solve most of the problem? It feels like today's industry comes up with new technologies without considering this from the beginning.
So yes, it will solve, but only for a specific section of the supply chain security. Because if you guys remember, when I'll just look for the slide right now. Okay, I'll share my screen again to be able to see it. I agree, it will solve, but only for a specific section, of your SDLC. So if you're moving in your pipeline right now to, let's say, to the build artifact, to the build pipelines, okay, and you're getting all the verification from your company, and you sign everything, great. But how do you know that it's not been tampered across the SDLC? How do you know that on your code repo, your local code repo, the adversary didn't hook into the system and tampered with it? This is exactly what happened with the SolarWing, if you remember. Because in the SolarWing, what happened is that all the artifact, the DLL, the code, everything was with the right signature, everything was with the right scan results, everything was working. It has all the right things. All the dots and all the I's were crossed and checked. What we still found this. We still encounter this attack. So my short answer is yes, it's a good thing, but it won't solve the entire problem scope, because the problem scope does not focus in on a specific. It goes from the code repo all the way to the runtime, to the actual deployment.
Thank you. What would be the core differences, to your point of view, between Renovate and Dependabot, so another product?
So one of the main things that I can say is the automation that introduced. Renovate from, and I mentioned that Renovate is an open source tool that 500 million people adopted, it's been downloaded. And also, it can also do the merge automatically and also give you the merge confident. Not only does the updating, the merge confident is a very powerful thing. So if I'm going to this slide, a second. So you see, you get full information, not only, okay, there's a new version. I'm giving you the statistic before I'm implementing. I'm giving you the statistic, okay, the adoption rate, the merge confident, and how many builds this fix has been broken. And you can also do fully automation. So if you trust this, tool, and you don't only want him to open the PR for you guys for the updates, you can also do having merge the code automatically. If you trust the package and you trust your code. So that's some of them. I don't want to get into a competitive question. Okay, so.
Okay. Where can I download the tools that you covered in your presentation, such as Renovate and Fresca?
So if you go to GitHub and type Fresca or type Renovate, you will get it as one of the first options. If you want, I can also share it. Give me a couple of seconds. I can share it on the chat or on, and you can send it to everyone. In the slide deck that is I shared also with the guys that organized the conference, they have the link. I planted the links over there. So if anyone wants the slides, just reach out to the conference guys and they will send it to him. You will have a direct link also to the reference architect and the supply chain security factory.
Thank you. From your perspective, what is the main challenge when working with cloud native artifacts?
The main challenge that I'm seeing is again the accurate security posture. I tried to address this when I talked about the SBOM, which is good, but it's not enough. But it's not only for the artifacts, because when we are looking at the entire SDLC, you have to gain a clear understanding on what you are running, where you are running it, and how it runs, and what's the difference, and when all these these components affect the risk posture. If I'll take a specific Docker image or an open source project and I'll run it on different environments, even if I'll do it only, I'll run it on AWS or in Azure, the infrastructure configuration will affect the actual risk posture. If I'm exposed to the internet or not exposed to the internet. If the open source package is running on top of Ubuntu or on top of Debian or on top of Red Hat images, okay, the security risk might change. So we need to have, the main challenge is to get the clear and accurate security posture of your artifacts.
Thank you. How far left should I shift my security tools so they will be effective, accurate, and provide me with actionable results? But in the meantime, I need to train all my developers. So what's your point of view on this matter?
So as far left as possible to shift, to be also to provide value, it depends on your day-to-day activities, on what you're working. This is exactly why I presented this. I'll show you the screen, why we have this slide. This slide, if you're right now working on your CI/CD pipeline, or you're working, you're a DevOps, which is focusing more to delivery. So I would say shift as far as the beginning of the pipeline. Scan the artifacts, but scan it when the entire artifact is near completion. Because as I said, the challenge that we addressed before, the risk posture, if I look right now only on the different components that I have and I'll scan them, so I won't have the accurate security posture. So only when I scan it as far as possible in the SDLC on my pipeline, okay, I will get the clear security posture. The same thing goes for the pre-build. If I'm looking at the pre-build, so my recommendation is to implement a good SCA solution right on top of your code repo, GitHub, Bitbucket, whatever. So you will be able to scan your artifacts right before they are being generated and pulled into the pipeline. So as far left as possible, depends on your boundaries of work.
Thank you. I'm checking on OWASP if we have any more questions. It seems that we answered all the questions. Thank you very much for your time. It's now the lunch break, so people, you can attend a new session this afternoon. That's over for my shift. So have a nice day. Thank you so much for your time, and looking forward to seeing you again. Bye bye.
You guys, bye bye.